This is the pre-lab for our specific heat of a metal lab on Thursday, October the 8th, honors chemistry. So let me talk a little bit about the lab itself. This lab is titled Specific Heat of a Metal. So in this lab, I took a metal, copper, I placed it in boiling water. Once it was in boiling water for approximately 10 minutes, I then moved it to cool water and measured the temperature change. This is essentially what you'll see for the 2 trials of about 20 minutes of the lab. Once you've finished watching the lab, you'll then need to take the data that you gather and write a lab report for next Thursday. So let's talk to you a little bit about the lab itself. The lab is based on the idea that specific heat, being an intensive physical property, is something that we can measure by taking and measuring the heat flow from a hot metal to cold water. Using that first law of thermodynamics, that whatever the hot metal gains from the boiling water can be measured as being lost to the hot water, we will then be able to work backwards and calculate its specific heat using our energy transfer equation, Q equals MC delta T. So first going to talk a little bit about the lab, then I'm going to tell you probably a good spot to pause the pre-lab and then come back to it after you've finished so that you can effectively write the lab report for next Thursday. So the title of the lab, again, is Specific Heat of a Metal, and our purpose is to experimentally determine the specific heat of that metal, copper. So you'll see that what I did is the same thing as that you would have done if you did this lab, is take the mass of the metal. Then I took that metal and I used the same one in both trials, and I added that metal to a beaker of boiling water. It's a 600 milliliter beaker that is filled somewhere between 2/3 and 3/4 of the way with water. That water is brought to a boil and the metal is placed inside. Ideally, the metal would be suspended so as not to absorb any of the heat from the bottom of the hot plate, the bottom of the metal touching the hot plate, but unfortunately, our metals don't give us that opportunity. Once this was placed inside of the boiling beaker of water, I then took the metal and I took the second beaker, I believe it was a 250 milliliter beaker, and I added 200 milliliters of water to that beaker. After a period of time, when it got close to when I was going to transfer the metal, I took the initial temperature of that cooler water. I removed the hot metal from the cold water, placed it removed the hot metal from the boiling water, placed it into the cold water, measured the highest temperature, and then I did this process all over again. So as you are getting ready to write a lab report, this is a first lab report for us, and one that I want to make sure that we are very clear on a few things. Many of you are used to writing lab reports possibly from your biology class or some other science class, and there are generally some differences between the way that they write them and we write them, and so I wanted to make sure that I pointed out those differences to you. First thing that we do in a lab report is we write the title, and so that's the title at the top, the specific heat of a metal. And so your lab report should have a title to it. Once we get to the end of this, I do have a sample lab on the far left that I'm going to reference. The next part of the lab is a purpose. The purpose of the lab should always be written as a complete sentence. So it's not written as to find the specific heat of copper. No. In a complete sentence, the purpose of this lab is to experimentally determine the specific heat of copper. So we have our title, we have our purpose. After the purpose is our data section. And you will notice that when you look at the sample lab, these things are broken into sections. Yours must be as well. You will put the purpose, the data. Obviously, the title doesn't need a section title to it, but every other section should be titled. And you'll see a deduction for that if that is not the case. So we look at data, and I have a data table already written out for you. One of the major issues that I find with the first lab, and even some labs after that, is for some reason, some people think that the data table given is a suggestion. The data table that is given is not a suggestion. This is the data table. And so I'll often get people who will stop the data table when we get to the calculated data. And maybe you learned that in a biology class, but for chemistry, that will absolutely not work. Your data table should mirror my data table. That's why I'm writing it, so that you get the idea, or at least the practice of seeing what information is important for somebody to succinctly be able to gather in one location. And that's what this is all for. You'll start with the mass of the metal. It's the same metal in both trials. That's why I just put one line for it. You do notice that you do have 2 trials that will be done in this lab. You have the temperature of the boiling water. It's not the same in both trials, and so that is broken apart. I should also mention, you also want to keep with the precision of the equipment. That means the mass of the metal should go to 2 decimal places. That means the thermometer readings, any temperature, should go to 1 decimal place. The volume of cold water is the same for all trials, 200.0 milliliters. Next one down here, the temperature of the cold water, you'll see that. And again, these are all in the video you're getting ready to watch, so there's no reason for me to write those all in. Once I finish that, you'll see the last thing that I will gather is the temperature of the final temperature of the system. If we're doing this, we're taking a hot metal. We're placing it into cold water. First law of thermodynamics says, whatever heat the metal loses, the water must gain. Now that is unless there's other things absorbing heat as well, like the air or the beaker or something else, my desk. But we're assuming whatever heat the metal loses, the water gains. And then we're also assuming that the temperature of the metal will race down as it cools, while the temperature of the water will come up. And the reason that the temperatures stay constant is we have reached thermal equilibrium. That's also why we're placing the metal in the boiling water for 10 minutes. By placing it in 10 minutes, you reach the same temperature. The final temperature of the water and the metal should be the same. The temperature of the boiling water at the top, that should be the temperature of the metal before it goes into the cold water. So then I go down and I start to do some calculations. I see the change in temperature of water, the heat gained by water, that is in joules. I don't know if that's clear, so I want to make sure you can see that's a J in joules. Change in temperature of the metal, specific heat of the metal. There's one for each trial. Average specific heat of the 2 trials. The actual specific heat of copper is 0.385 joules per gram degree Celsius, and then the percent error. So at that point, we have 1, 2, 3, 4, 5, 6 calculations. I think now is a good time for you to watch the lab. You need the data table so that you can collect the appropriate data. Take the time now to watch the lab, maybe pause, stop this video, because if you continue on, it may not have as much meaning if you don't have any data to use. So I'm just going to pause myself for a second. And once I pause for a second, I will give you that opportunity to maybe pause the video, and then I will continue on with the next part of our lab report. Remember, we have a title, purpose, and data. So here I'm pausing, watch the lab, and then come back. Okay, it's hoped that at this point you had watched the video. Now it's time to move on to our next section of the lab, and that is filling out the rest of that data chart with your calculations. First thing you'll notice, again, I labeled the calculation section, and the calculation section, you should also have a short explanation, or I guess a short statement as to which trial you are showing. Now, what do you say? Why am I showing a trial? The idea is that there is not a need to show all calculations for both trials, only one. Since you will be doing the same thing twice, there's only a need to show them once, but you should tell the reader which trial you are showing, so I did that. The following calculations are for trial 1. Now, I could also continue on and say trial 2 is done in a similar manner, but that's fine to tell the reader that you are showing trial 1. You would next then give each calculation a heading, and then you would give the actual calculation, the word description. So what is the change in temperature of water? Well, delta T of water equals the final minus the initial temperature of water. So not only do you give the word description, you also then show this with your numbers. And so when I look inside of here, if I look at your numbers, I should have seen the final temperature for trial 1 was 25.1 degrees Celsius minus the initial temperature of 22.8 degrees Celsius, leaving me with some number in degrees Celsius. Okay, so that would be my change in temperature of the cold water sitting on my desk. Then we next moved on to our second calculation, which I believe, let me go back up here, that was the heat gained by water. Heat gained, that's Q, equals MC delta T. The mass of water, well, there's 200 milliliters, so 200 grams of water. Specific heat of water is 4.184, and the delta T of water is the number that we just calculated. We'll put in our numbers, and we will get a value in joules. Number 3 was our change in temperature of the metal. So the delta T of the metal, let me write that down. I got ahead of myself. I'm so excited to show the calculation, I should actually write down what it is. The change in temperature of metal. Delta T of the metal equals final minus initial temperatures. In your case, the final temperature of the metal and water are the same. Remember, they reached thermoequilibrium. This initial temperature of the metal, this is before it goes into the cold water, and this should be your temperature of boiling. So in this case, yours was 102.9. When I get a number, it will be a negative something degrees Celsius. Right? I should have a negative temperature change because it would seem to me that my final is much smaller than my initial. Number 4, fourth calculation. Go back up to the top, see what that fourth calculation was, count those down. Change in temperature, 1, 2, 3, looks like specific heat of the metal. Okay, so specific heat of metal. Well, specific heat is a part of the Q equals MC delta T expression. Now it's the heat that the metal lost. So remember this. Whatever heat the water gained, the metal lost. This is equal to the negative Q of water. So what I'm going to do is I'm going to figure out however much heat the water gained. I got that number up here, so I will get the negative joules from number, what number was that, 2? Take number 2 and make it a negative, equals the mass of metal. Let me erase this for a second. My mass of metal was 70.54 grams. Specific heat of the metal is X. Change in temperature of the metal. This was calculation number 3, right? And then as I solve for C, I will get some number in joules per gram degree Celsius. Notice that my Q and C are both negative, which guarantees me then to have a positive specific heat of the metal. Okay? On to calculation number 5. Calculation number 5, going back up to my table, looks like I have the average specific heat of the metal. So average specific heat. So we're going to take trial 1 plus trial 2 all over 2. Can't give you numbers for that because that would mean I'm giving you all of the calculations. So don't forget to show the numbers. Okay. Number 6. 6, I believe, is my percent error. Is that right? Yep, that is my percent error. So for percent error, you do the percent error by taking the average minus the actual all over the actual times 100. The average would be calculation number 5. The actual is 0.385 all over 0.385. And again, when I say number 5, remember that is calculation number 5 times 100. Okay? And I will get a percent error for the trials. You have a title, you have the purpose, you have the data, and you have the calculations. This is just showing you the list of metals that we normally give in class. With the one that we did is copper. It's 0.384 something, and we rounded it to 0.385. That's fine. Now, what do we do after calculations? Results. The results will always support the purpose. The purpose was to find the specific heat of a metal. And so, what is the average specific heat of the metal? Be sure to put this in a complete sentence. You have to do this with units. You have to do this to the appropriate number of significant, digits. Yeah, we haven't done that. So make sure you have to do that to units. Conclusion. First part of the conclusion is a summary of procedure. Now, when I say a summary of the procedure, this is not a step-by-step procedure. This is, again, a summary. So you're not going to go back to the front, what we did way up here, and just copy this word for word. That's not what I want. What I want is you to summarize what was done in the lab. So let me give you an example of what a summary of the procedure for this lab would be. Copper metal was heated in boiling water for 10 minutes. It was then transferred to a beaker of cold water. The temperature change was measured, and the specific heat was found. Now, you'll notice those are not a set of step-by-step instructions. They are not a procedure for the lab, but also when I think about it, that's really what you did. I took a metal, I placed it in hot water, boiling water for 10 minutes. I transferred it to cold water, and I measured the change in temperature. Then you're going to give me the result. What is your specific heat for trial 1, trial 2, the average, the actual, and the percent error? All of those things need to be included. What did you get for trial 1, trial 2, the actual, the average, and the percent error? Okay. We have a summary of the procedure. We have the results of our procedure. And then we have our error analysis. Here we give 2 errors and how it affects results. You will have one of 2 types of results: high results or low results. If your results are high, let's say both trial 1 and trial 2 are high, then you give high errors. If trial 1 and trial 2 are low, you give low errors. If one is high and one is low, then you give one of each. So as I look down here, let me give you some options for your error analysis. If you have high results are a function of heat being gained. Well, where is heat gained? This is being gained from the hot plate. The fact that it sits on the bottom of the hot plate can cause a larger temperature change in the water than you should have. Second, so it leads to a higher temperature change in the water, right? Therefore, high specific heat. When I add the metal to the water, some of the water splashes out. When the water splashes out, I get the same results. Less water, greater temperature change, higher specific heat. Let's see, anything else? Oh, I did say hot spots. So this is kind of the explanation for what's going on here, by the way. Hot spots. When you put your thermometer in, if you haven't dissipated the heat evenly, let's say it was really close to the metal and the rest of the water was still a little cooler, it just hadn't spread the heat out to the whole water yet, you'll get a hot spot, and hot spots lead to a false high temperature. What would happen is eventually over time that temperature would come down, and maybe we didn't wait long enough. Low results. Low results is an indication that heat was lost, leads to a lower change in temperature. So heat could be lost in the transfer of the metal to the cold water, lost to the air. Heat can be lost while it's in the water to the air, the beaker, and to my desk. And then finally, when I'm stirring it, I haven't waited long enough. Maybe the heat has never reached its final highest point. This is your lab. Couple of other things to think about when you're writing the lab. One, these are not bulleted points. Everything is written in paragraph form. Secondly, we are writing in third person neuter. Now, you may not know what third person neuter is. Third person neuter means you do not use the terms I, he, we, she, they, the experimenter, any of those. To be quite honest, I know that people teach you how to do that in other classes. It's not professional type of writing. So a professional type of writing, when you would move on to a higher level, wouldn't say, the experimenter found. They would never say that. What the person would say is, it was found. And so third person neuter never mentions the person doing the lab. It's just assumed you did the lab. So let me give you an example. If I said to you that the metal was placed into boiling water, I wouldn't say I placed the metal in boiling water. I would say the metal was placed in boiling water. It's just assumed then that I did it. If I wanted to say some errors, I wouldn't say that I held the metal out of the water too long. No, I wouldn't say you held it, Mr. Latanzio held it. No, I would say the metal was removed from the water and lost heat to the air. That's it. I don't reference any persons in the lab. That's third person neuter. So if you need to see an actual example of this, that's why I attached for you to the Google Classroom, a sample lab. Now you will notice it's a similar lab, but not the same lab. And so you'll see that it has a purpose. And I explained to you what the purpose is. I gave you an example. I gave you the data. I explained the data, and I gave you some hints as to data tables. I talked to you about the calculations. Notice the calculations, word and numerical descriptions. I go into the results. Notice my results. Complete sentence form. I explain that to you. Notice conclusion. I give you a statement about what's supposed to be in the conclusion, how to do the conclusion. And notice that also when I read this, it says, by heating two unknown metals at a constant temperature in a boiling bath of water for 10 minutes. Notice that it doesn't say I, he, we, she, the experimenter. Notice I also summarized the whole lab. I did that in 1 to 2 sentences, as you should as well. Notice also my conclusion is written in paragraph form, as yours should be. Once you get through this and you want to look at some other things, I will reference this many times when I grade your lab. This is the rubric for a lab report. Do you have a title? Is your purpose not in a complete sentence? Have you not used all of the data? You can see that where I'm going to take points off for data not being there. Do you have units? When you've done your calculations, here's one. Your calculations are not labeled, -1. They are not in the format that we use, -1 or 2, depending on how you've done it. No numbers given, -3. Only numbers and no formulas, -3. So you can see all of that. Calculations done incorrectly, 1 to 2 points off per, depending on what it is. Results must be in a complete sentence. Notice all of these. Everything is in there. And then it kind of goes through. Here's your conclusion, what's supposed to be there. The format of the lab. Notice that it does say no labs are in pencil, period. And that's not negotiable. Number one, if you were handing them in, I can't read them in pencil because they get smeared. I absolutely cannot read a lab in pencil that has been photographed and uploaded. It'll either need to be typed or in blue or black ink pen, one or the other, and then uploaded. Grammar things, misspellings, conclusion is one large paragraph and not broken up into smaller paragraphs, inappropriate use of punctuation, incorrect use of person, not using third person neuter, using it one to two times, half a point, using it more than that, and you will lose 1 full point. Later in the year, we'll talk about the use of significant digits, and you would see as you go through here 3 to 6 significant digit problems, and we give you 1 point docked. I think that's a pretty comprehensive discussion of this lab. You have 1 week to do it, not because you need a week, but because that gives you the time to ask questions. Okay, if there's any questions for me after doing the lab, or at least watching the lab, after listening to the the pre-lab, and then finally after doing our watching the lab itself, looking at the sample lab, if you have any questions, definitely ask. And this is a good place for us to stop with the specific heat of a metal lab.